Talk shoes. Recorded live.
Welcome to the Virtualization Security Roundtable podcast episode number 80. We've been doing this now, for 40 months? Something like that? Anyways, that's very good. Let me tell you who our panelists are today. Eben Rodriguez, who is a architect at eBay, I believe. Is that architect role?
Yep. That's right. Hello, everybody.
Michael Berman, who hopefully will be joining us a little later, is the CTO of Catbird. Boris Stronglin is a co-founder and currently VP Advanced Products at HighTrust, who hopefully will also be joining us later. And my name is Edward Halecki, a.k.a. TextIWill, in the VMware Communities Forums, and author of the book VMware vSphere and Virtual Infrastructure Security, Securing the Virtual Environment, as well as VMware ESX and ESXi in the Enterprise 2nd Edition. You can find both of those on Amazon. A special guest panelist this week is Alan Bollinger, who is the CTO of OnSystem Logic, a security consulting company and Symantec partner providing security consulting, engineering, and training services. Most recently, Alan has assisted Symantec in enhancing its critical system protection product to provide comprehensive protection for virtualized ecosystems. And that's actually what we're going to be talking about today. The critical system protection, or CSP product from Symantec, has been intriguing me for a couple of years. And when I was at RSA conference, I bumped into the CSP guys once again, and they finally showed me something that actually applied to everyday virtualization security that I found, instead of just guest security, but actually the hypervisor itself. So welcome, Alan. Welcome, everybody, to the podcast.
Thank you.
So, Alan, why don't you give us about 5 minutes on what CSP really is?
Sure. It's a endpoint security product, so it would be sort of a complementary product to something like your antivirus capabilities you would have, but it does its protection and monitoring in completely different ways. So one of the primary components of it is this protection engine, which is actually an enforcement of each individual process and application that's running on the box and limiting what resources that particular application can access. So that includes things like network access, file, registry, devices, memory control, and it's doing all of this under a particular policy environment, which is very rich for determining what the behaviors are that you allow individual applications to perform on that box. So this idea of sandboxing every application is just sort of one half of the product. The other half is doing sort of, I call it, traditional HIDS functionality, where it's looking for change detection events on your system. A file is changed, or the content in that file is changed to a particular value that you don't particularly want to have set, for example. It's also doing general log monitoring of anything that's on the box. So if you wanted to monitor, obviously, your syslog or Windows event log and application log files, you can be looking for security events in there. So it's this combination of both traditional HIDS, if you will, log monitoring, change detection, combined with the ability to provide overall system lockdown using this sandbox technique, which is now becoming far more prevalent. You're seeing it in press more, where individual applications or vendors, for example, Chrome with their web browser sandbox, or Adobe Reader sandboxing its app. What CSP is doing is essentially sandboxing your entire system, each application at a time, and more importantly for customers, the out-of-the-box policies already understand the common environments, whether it be Windows, Linux environments, Unix environments, so that there's no major effort required from the customer to deploy this. And then, of course, then you can expand upon it and sort of protect or monitor your application stack, that you may have your own applications, or in this particular case, what we're talking about is sort of the VMware stack of software that would be running, for example, on vCenter or on an ESX box that you would like to protect. So sort of in summary, it's a endpoint protection product. You apply an agent to the system, you sort of instantly harden that environment, provide this new visibility into what's happening on that system that you didn't have before, and then basically gaining assurance that your system, maintaining the integrity of that, and then preventing, for example, data tampering to important resources on that system, including the binaries, including the log files being produced by various applications, including locking down access to things like SSL keys. So it's this sort of combination of capabilities, doing this in a policy enforcement technique where you are able to control all of these functions and security aspects from a central management system, central event collection, and then basically giving you assurance of what's going on those systems so that you can basically sleep easier at night.
So let's go back to this. So this is, explain what a HIDS is, because I'm not sure a lot of people understand the technology. HID means so many different things.
Right, absolutely. And in fact, it gets confused oftentimes with intrusion detection that's occurring at, for example, the network perimeter. What we're talking about is host-based intrusion detection, meaning that you typically have an agent on a system. You can do some of this agentless, but to get sort of the full features and capabilities, you have an agent on the system, and it's essentially observing activity, particularly significant change events that are happening on your system. And so this is more along the lines of passive monitoring. You're seeing that a file has changed, or that this INI setting has changed, or this host file, new entry's been added, or this etc password file, something's been added to that. And so you're triggering on those events occurring, again, specified by a policy. And again, for most systems, there's sort of a general list of things you would like to monitor for. In addition to just seeing files change or registry settings change, you would like to also monitor sort of the wealth of information that exists on these boxes in terms of these logs. So again, your Windows event log is certainly one source of information, same with syslog on Unix systems. And so you can be looking for things, for example, call them login hack attacks. You can set up policies that say, well, I want to monitor when there's multiple login failures, and while you might see that as a standard function of Windows for logging into Windows, you can apply these same techniques to other log files, maybe logging into an application, logging into a database. If these things are being recorded to log entries, you can set up various rules to monitor this kind of data, looking at things like Tomcat logs or any sort of application logs that might have information in there. So that's what's traditionally been called host-based intrusion detection. The basics of this kind of technology have been out for more than 15 years, and of course there's a number of vendors in that space.
So in order to use this, it requires an agent on the individual guest or a physical machine. But when you're using it from the hypervisor, you're actually protecting the endpoints that talk to the hypervisor.
Right. So in general, what you're going to do is you deploy this on all of those endpoints that are sort of critical in your infrastructure. So that could be a vCenter server, it could be a hypervisor, it could be the client system that's doing the access to those critical assets.
Or as we say in a protected environment would be the jump machine you're using that's actually accessing using the vSphere client.
That's right. So, but again, the HIDS is doing more of this passive observation. It's the other side, what is sometimes referred to as HIPS, host intrusion prevention capability. But CSP goes beyond what I'll call just basic HIPS, where you're just basically intercepting the access to the network or access to a file, to incorporate this idea of sandboxing, where you're taking a complete view of what resources for this particular process, whether it be your vCenter processes or the RPC process on Windows, the spooler process, things that are the normally attacked vectors, if you will. By sandboxing it, you basically limit these things that are highly privileged, they're running as system or running as administrator if you're a logged in user, and basically being able to control this beyond the controls that the normal operating system provides, so that you're saying whether or not this user can not only run this app, but what resources can be accessed. Or, for example, I only want this particular file to be accessed when it's coming through this particular editor tool, configuration utility, for example. I don't want people editing the files directly. They need to go through a particular process or application to do that. So in essence, what you're really doing is locking down the system so that processes only do their normal expected behavior, and even though they're running highly privileged on the system, if the process were to be subverted, let's say by a vulnerability in that spooler, RPC, the transaction service, terminal services, any of these processes would be subverted because of some vulnerability, they're not going to be able to be used to take over your system, to install rootkits and executables and change the registry auto run keys, because these services that are running on your box don't do that. That's not their normal mission in life, is to install software and change critical system settings. And so by sandboxing them down to precisely what they need to get their job done, which name pipes do they use, which devices, which files do they access, where do they live in the registry hive, then you can get this very tight containment around these, again, typically attacked processes. And of course what we're seeing is many attackers moving up beyond just the basic OS attacks, now focused on application level attacks. So an application might be a Tomcat, or it might be Tomcat when used by vCenter, for example, or Jetty, or the Java runtime engine. So these things that have vulnerabilities in them, you would still want to, the vulnerabilities will always exist in all software all the time. So it's a matter of, can we contain any exercising of that vulnerability such that they can't break out of the sandbox that's in fact running at the kernel level of the operating system. So there isn't some special user mode process that if you killed it, all your protection goes away. This is essentially built in at the kernel and providing this interception. And
so let me ask
sure,
a couple questions about that. Right now, we don't have, let's put it this way, each virtual machine, each guest in any hypervisor effectively is a sandbox that talks to the hypervisor. However, there's a lot of ins and outs, and there's no real protections in that sandbox that we know of. There probably are a bunch of them, but we don't know what they are. If something like this could be employed as part of the virtual machine manager, it could actually add even more protection, specifically from escape the VMs. Would you concur with that or not?
Well, certainly, again, the primary deployment is people are deploying CSP on these guest environments. And so you're trying to protect from these exploits, again, exercising your machine. If there is a way, for example, though, that you can do a copy and paste between VMs, and it's, I'll call it outside the purview of that individual VM, it doesn't even know that this other activity exists where you're doing, let's say, a copy and paste function, then at the VM level, CSP isn't going to see that.
Well, no, but I'm talking more generically than that. And that is that I'm allowed to do the action like right to the screen. If I overflow the screen buffer, which is an action that, because of the way it's defined, may be completely and utterly allowed through CSP, but it's something that would literally right outside the sandbox or right into an area of the sandbox I should never be allowed into. Unfortunately, since it's below the virtual machine's kernel, you'll never know that. Right?
Right. So something that's
So I'm
really
saying is it possible, I mean, I'm thinking generically of putting something below the VM. I'm not sure. I know CSP doesn't do this right now, but just thinking, of the future, it'd be kind of nice if it was actually below the VM so it could actually block everything from coming out of the VM that should never be out of there, because it only has certain device drivers that are allowed. Anything that's outside these memory ranges go away.
Well, when you're saying sort of below the VM, that's what I would call the hypervisor, right? The hypervisor is...
Well, there's a layer between the hypervisor and the VM. It's called the virtual machine manager.
Right.
It's the sandbox per VM.
That's correct. But then that environment itself is being controlled and configured at the hypervisor level.
Yeah, but if I break out of the VM, I end up in that sandbox. I should never be able to get into that sandbox from the VM at all. That's called escape the VM. That's what everybody's worried about.
That's right.
Whether it's true or not.
Pretty rare.
Yeah, but is that outside the scope of this product?
Right.
I'm talking future.
Well, CSP at that level is not down into VMware's own kernel virtualization module, which is doing this part. So we have CSP in the guest, and we have CSP that can operate in the ESX hypervisor realm. But down in sort of the level where VMware is itself creating this virtual sandbox. Now, CSP is not in that level of code, or it would be extremely difficult to vet those VMware kernel operations as whether they're valid or not. So CSP is not attempting to do that. So it's really operating at the OS level, application level, both sit the guest, and again, there is an agent that runs on an ESX hypervisor, because again, if I can subvert the hypervisor, well, I can essentially configure...
Well, no. Well, you're not saying the hypervisor, you're saying the management appliance, because
right.
no one can get to the hypervisor.
Right, on ESX is called the console operating system. So that's the management layer that you would need to protect at the higher level.
Well, and inside of Hyper-V, it's called the parent domain inside of, a parent partition inside of Zen and the KVM. It's the parent domain. It's still the management construct that surrounds an ESXi. It is still a management construct.
That's right.
So on ESXi and server core, you actually aren't. Are you still installing an agent at that time, or are you just using some other mechanisms?
No, that's right. So on ESXi, VMware doesn't really provide support of installing an agent that would in fact be sort of managing the ESXi shell environment, or if you think about the console management that takes place there. So in that case, since we can't put a native agent right on an ESXi system, what it's done is sort of monitoring at a distance. So what's called a remote edition capability is you're basically saying, well, I can't put an agent on the box, so we do lose the prevention, this sandbox engine that we have on all the other platforms is not available for ESXi. The detection capabilities can do the log monitoring, can do the file integrity monitoring, again, using the VMware APIs that allow you to pull over these objects that they expose, and then sort of be able to detect, okay, here, this config file changed, and these were the changes in it. Or this was a VMX file that came over, and we can monitor, did the VMX settings change to have some of these conditions or options being set that VMware in their hardening guidelines say it's not a recommended thing to do. So there's about a dozen or so of those that if you detect this condition occurring in a VMX, you might want to send an alert up that this is sort of violating the general hardening requirements. So on ESXi, because of the nature of that environment, essentially what the product is doing is the monitoring that is capable and is exposed through these, essentially through the file transfer mechanisms of getting the various config files off the box, getting the various logs, for example, auth.log, shell.log, things that aren't normally showing up in the syslog event stream, but has some very useful information. You might want to know exactly what's going on when people do get connected and logged in directly. Monitor.
But it's still a very limited subset of files, regardless of log names. I mean, all the logs are allowed, but the config files, it's an extremely limited subset, is it not?
That's right, and that's the condition of the way VMware has set up its configuration file, an XML file that determines what files they will expose and not expose. And if the customer chose to modify that and expand the list, then you could expand the list of files that could be retrieved. Yes.
Currently does CSP support Hyper-V or any of the other hypervisors?
Certainly when systems are running as guests in those environments, just like guests on a VMware system. In terms of the management level policies that, for example, Symantec has just come out with, where the complete sort of application stack has been, policies, specific policy content for that has been done. That hasn't been done yet for Hyper-V or Xen, but in terms of the base, for example, on Hyper-V, the base Windows protection would still be there. So just like today, you would deploy CSP on any range of Windows systems. It could be 2003, 2000. You just deploy your agents, and your policies would protect that because Windows is still Windows in terms of the core operating system processes that are running there. But it's this additional functionality of just out of the box. Okay, this is vCenter, and here's the update manager, and here's the ESXi dump application, and all of those application level elements have been more precisely sort of configured right out of the box, where you can just deploy a vCenter protection policy and a vSphere detection policy to monitor and protect that system right out of the box. So, one could assume that additional environments would be supported by Symantec in the future.
So, do you support Linux today?
Absolutely. So, CSP runs on various flavors of Red Hat, including CentOS. Same with the SLES environment, SUSE environment. Again, multiple versions. So, like Red Hat 3, 4, 5, 6, and the same sort of levels of support for SUSE environment, and then additional Unix environments as well, including Solaris, including AIX, for example, HPUX, various Unix environments, the typical things that one would see in an enterprise, and the sort of level of support, multiple kernel version levels across all of these environments. The product's been out on the market for close to 7 years, so it's got a rich set of platforms that are supported, and in addition to, of course, all the Windows kind of environments.
So, Michael, you do a lot of stuff with IDS, IPS. What do you?
I do.
Yes, you do. And how do you compare that to what the hits that we're talking about here?
Well, the solution our solution is a network-based. So there's a sort of a clear delineation, and this is looking at the malware problem from the host and from what I would call a known behavioral profile of the applications on the host. So architecturally, let me ask a couple questions. This sounded a lot like, if you might recall, B-level secure system design, where you have a monitor, and the monitor, you have either access control lists or other access control mechanisms, based on the subjects and objects of the system. and that monitor locks, particular applications down to, particular files that they can access. So this sounds very similar to that architecturally, especially when you talk about, being able to control that this application can only, you edit this file using this editor, not some other editor, which is, reminiscent of what you can do now, on all the standard Linux systems with like sudoers file. You have a specific sort of instantiation that you're supposed to use to edit that file and no other editor. So would you say
and
that
everybody uses that, right?
Well, no, that's not my point, Ed. I'm just saying you can do that lockdown. So this architectural, so CSP architecturally is like that B-level user and application monitor. So would you say that's true?
Absolutely. Everything you just said is the basis in the paradigm, if you will, about how the CSP prevention engine works. And in fact, much of the approach is following, in fact, many of the developers, original architects and developers of the technology had done trusted operating system work for certain agencies of the government, where this was a very hot topic back in the mid-90s of can we create a B2 or A1 level operating system, and it was done. I mean, the government funded a lot of work. It's just at the end of the day, it became totally unusable by customers. It was far too complex, and so a lot of that kind of went away. With this technology,
that's my next question, right? So how do you develop these profiles? So here's my question. I mean, are you shipping it and, you know a lot of the common applications, so you've already got the sort of lockdown profile for, I don't know, MySQL or, Microsoft Word, but then does it have a learning mode? I mean, how does a customer lock down, say, an enterprise application that you would, of course, know nothing about because they created it in-house?
That's right. Now, these are great questions, and these are all sort of the standard questions that always come up in customers' minds. So, first of all, absolutely, there's already pre-built policies that already understand all of the standard operating system environments. So again, on Windows, it's not only the 24 system services you typically see running on Windows and all the instantiations of different service hosts, because this version of service host does this functionality, but when it runs with these command line arguments, it does this other functionality. All of that's already been, like you said, pre-profiled and already done by Symantec. And so out of the box, you're getting this sort of tight level confinement, this sandboxing is taking place on those. And to your point about, well, this required, it is called sort of a mandatory access control system, and SC Linux that most people are familiar with is an implementation example of this class of technology for Linux. But what CSP is trying to do is this exact same functionality more heterogeneously across your environment, saying what you have with SC Linux, which some people find very hard to operate with, it doesn't have central management environment, ease of deployment and all these kinds of things. But take that concept and do it across all your OSs. Do it across Windows. Do it across Linux. Do it across your Unix systems. Have one common policy style such that you're protecting these resources where you could say, well, I could probably do something on Windows with the Windows firewall to protect ports this way, and I could do IP tables on Linux this way, and there's a different flavor of IP tables on Solaris and those kinds of things. The idea is to provide one common sort of management interface such that you're configuring firewall rules the same way across all the platforms. You're configuring file access the same way on all these systems. Device access the same thing. So the idea is to provide this common level of functionality and security and enforcing your enterprise's requirements using this particular management environment. So, for example, if you don't want IIS on a particular system to be running WebDAV, because WebDAV is seen as perhaps a highly insecure mechanism, you generally either rely on your IIS administrators to do that, maybe push out a group policy on Windows if you want to control it enterprise-wide. Essentially, you would have that same level of control as a checkbox item in the policy that says, oh, do I want WebDAVs to operate? Do I want News or FTP to be running out of my IIS system? So yes, out of the box, all of what I would call certainly the core operating system environments, the sort of the core applications, like on Windows, it's IIS, it's Exchange, it's SQL Server, it's the Office Suite, it's Explorer, Outlook. These kinds of things are already done for you in terms of literally out of the blocks. You can just deploy this, and it comes with sort of a granular way of enforcing. If all you want to do is apply the policy and put it in what we call sort of global monitoring mode, where you're just like, well, don't block anything yet, but tell me things that would have violated the policy, and let me see the events for that. And that's where you'll instantly get visibility that says, oh, I didn't know this application goes and drops these executables on the system. Oh, I didn't know it's doing this networking. And
are we talking about Chrome now?
Well, in fact, see, what this is, Chrome is one application example of this, and Google has done a great job of getting the mind share out there that says, look, sandboxing really moves the needle in terms of security, and that ultimately, if you look at all the mobile environments, Android and Apple, every app that you install is isolated, right? Is running its own under its own user account, and it comes with a manifest that says, well, what resources is this app allowed to access? Now, of course, they're a little bit too coarse, right? Oh, can I get access to the
or Android's a poor example because it seems like they've implemented that security mechanism poorly, but
right, but the concept
let's go away from let's say that.
Yeah, but let me. I had a different question that was more sort of technical. So you mentioned device driver, but this really isn't a device driver, is it? Because in order for this monitoring to be working, you must be essentially shimming the entire system call interface. Is that correct?
That's right. Yes, that's right.
And then are you also getting in on the I/O? I'm a Unix guy. I always say this. The I/O control interfaces as well. The IOCTLs on a Linux system.
That's right. Now, what CSP is not doing is in line with every I/O operation, right? So essentially, think of it as an access control system. For example, take a database application. What it does is it starts up, and it has to obviously open up all of the database files and transaction files it needs, and then it's going to do billions of I/O operations. Well, CSP, once it's granted access and says this application, this Oracle or this SQL server needs access to this file, and we only want it to do that file, and we don't want any other process to be mucking with that file. So basically, you're going to be able to say, this is what Oracle does. But once the access has been granted, all the I/O that takes place back and forth, writing the disk for heavy activity and stuff like that, CSP is not involved. So in fact, this
is that true? Is that true when we're using the same file handle, or would you get in there every time it closes and reopens the file?
No, every time it closes and reopens the file, it would be saying, okay, you're reopening it. Let me make sure the policy hasn't changed, and make sure that right now, at this very instant in time, you're allowed to access that file.
Right. So you're looking at it. You're looking at the open call, but once the stream is open, you don't look at it after that. Right.
And it's the same way the firewall works. So if you're allowing your web server to operate on this port and operate and talk to this remote IP address, and you're for this application, and running under this user account, and it also sort of follows all the process launches, saying, okay, only when this is running under Service Control Manager. So there's a bunch of conditions. It says it's not just, oh, can this app access this resource? It's got these other context-related attributes. It says WinZip, when it's being launched by this program, can do this, but WinZip, let's say run by an individual interactive user, they get a different control behavior.
Well, let's think about that for a second. Say I'm a PDF. When you say open the PDF, you would check. Yes, you have the rights to open it. But PDFs have been known to mess around and scribble in memory where they're not supposed to be. How do you protect it from scribbling in that other memory?
Right. So now we're talking about if it's scribbling in its own memory space, that would typically be allowed. But if it's trying to scribble into the memory space of another process,
say the kernel.
Well, if it's the kernel, and typically Adobe wouldn't necessarily have the ability to write into the kernel. Well, of course, maybe if you're running as a really privileged process to do that. But generally what you're seeing when you're seeing Adobe exploits is what's happening is you're running as administrator. You're on your box as normal. You're on your laptop as an administrator login. Adobe runs, and it's breaking the, here's it's just a simple rendering program that shouldn't be, it should be all benign activity. So what CSP is doing, and this gets back to one of the earlier questions, it says, well, do you have to profile every app, and how can you know, the 100,000 applications off running on Windows, is there's different sandboxes available that say, well, if it's not one of the ones that are sort of pre-known by CSP, let's put it into these sandboxes of what we call well-behaved applications. And so if you're an interactive user, you're running Adobe, well, a well-behaved app doesn't go right into other processes' memory space. It doesn't generate buffer overflows. It doesn't go install software. It doesn't go change the registry run keys. It doesn't, muck with sort of critical system files or devices. So what we find is that virtually all the apps that the system doesn't know about, if it's a well-behaved app, will operate just fine. It's only when that Adobe Reader app is doing this, PDF is now trying to say, oh, well, now I'm going to use the fact that you're running this as administrator. I know you have complete system access. I'm going to go right to this registry run key. I'm going to go drop this rootkit onto the system, and that's the exploits that you worry about, is containing it to the process that says, oh, you can only do well-behaved things. So you could drop maybe a text file on the system, but you wouldn't be able to launch it. You wouldn't be able to, you certainly can't drop executables onto the system, nor is it a good idea for things like Reader to necessarily go off and just spawn other children and say, well, let me go run command.exe and go add a backdoor user account onto the system. So the whole idea of the sandboxing is contained. It doesn't fix the vulnerability. The vulnerabilities are always going to be there in software. The idea is, let's contain it when it attempts to do anything that's outside the norm. And some of them, again, we can have very tight sandboxes, let's say for the RPC process, chapter and verse, everything it does. And then there's going to be a general application. Who knows what Adobe Reader does? Who knows what this poker program that you like to do? But generally, we don't want these programs that we download and run to be talking to China or Russia.
So
and the idea that this is all occurring on the host itself and providing this containment of what you want apps to do, and you're able to, at a management level, control what do I want to enforce from an enterprise standpoint.
So one of the most recent vulnerabilities for the vSphere product line, for example, was the ability inside the vSphere client to bring in a log file, open it up, and write malware right there, to write something that will allow you to run it later. And how would this block that from happening? Assuming I had CSP on the VM or guest or host in questions running the vSphere client.
Yep.
vSphere normally goes off and gets web pages and downloads bunches of things from the servers. But during that read period, it can't write back generally, it can read. There's a possibility that malware could be inserted. How would it handle that case?
That's right. So now exactly that. We've got the client in its own sandbox essentially, and it's very limited as to, again, it doesn't normally go right into the system area. It's not It's suddenly not opening up an outbound network connection. So when you have an exploit, it can do a whole bunch of things. One is to drop a script on the system, which I think is what this particular vulnerability was talking about. Was the idea that, well, you could go run a script and make it do something that would obviously expand the scope of what client is designed to do. So the sandbox controls would, in fact, stop that kind of activity.
Okay. So as long as vSphere client was within inside of a sandbox, that activity would be completely and utterly blocked.
That's right. Now, again, it's still able to read the content that had the malicious behavior in it. The malicious behavior, it's like when it attempts to do something that is outside the realm, that's when it stopped. And this is one of the things that is very different when you're at the management console looking at events, because CSP is not looking for named malware, right? It doesn't know CVE entries. It doesn't know, let's say Stuxnet by name. All it knows is, for example, with Stuxnet, if you had CSP on your system and Stuxnet was there, well, this is actually a very interesting demonstration to show the different attack vectors of Stuxnet and how they were shut down, just using the standard policy, not knowing any specific applications at all. It's just standard Windows policy. Stuxnet was trying to do buffer overflow. Well, that happened to be detected and stopped. And it was also trying to do memory injections and migrations from process to process. That was detected and stopped. It was also had one of these sort of just send a specially crafted file to any of the systems on the network that were acting as a print shared printer. So I could just send Stuxnet would send this specially crafted malware document to the remote system to have it print, and basically it took over the spooler process on that remote system. This is one of its ways it was able to sort of get on the one box and then spread itself to other boxes. It had multiple spreading techniques, but this was one of them. There was 4 zero-day vulnerabilities in Stuxnet and about 8 others, I believe, total. And this was one of those. And the way the policy blocked that particular activity was, Spooler's now trying to write into the system directory. Spooler doesn't do that. So let's stop it. So you'll get an event in the console that says Spooler was trying to do this and the activity was stopped. It doesn't say, Stuxnet's doing it, because it doesn't know. It's not looking for patterns and is it this malware, that malware. It's just looking for activity that is abnormal. And of course, another thing that Stuxnet was doing was it would store its malware payload in a SQL Server database, because in this particular industrial control system, the username password of the SA account for SQL Server was a well-known published information, and so it was able to just simply log into SQL Server, which is normal activity because it had the right SA credentials. It then created a table in the database, stored its malware payload in the database itself, so that if you suspected something was bad on your system and you went and you re-imaged your system, well, what this thing would do inside a SQL Server is wake up periodically, detect whether it was still infected on the system, and if not, it would shell out of SQL Server instance to the operating system and then reinfect with the payload. Well, again, this is stopped by the default policy because SQL Server, as with most of these services, shelling out from the environment to the operating system is not good practice, and so that was stopped as well. So it's instead of looking for specific attack vectors, what CSP is doing is just saying, I'm just going to stop abnormal activity. Having SQL Server shell out to the operating system is not good standard practice on these systems, so let's stop that by default.
So effectively, let's go back to virtualization here and the cloud.
Yep.
If I'm dealing with my management components, right now we always say to isolate your management components from everywhere and then firewall them off and make sure everything's well protected and use strong authentication. We can add to this list of things now the ability to do something like the CSP instead of just antivirus, anti-malware. Use CSP for certain applications to only have access to what they need. Lock things down even further. And then furthermore, you actually are able to communicate with the ESX and ESXi hosts using the same construct to gather information about them.
That's right. So the idea is now you've instantly hardened your Windows system, and you've hardened the application tiers, because what you want to do is you want to protect the operating system from sort of bad apps or bad malware, but you also want to protect your applications and particularly your critical sensitive data and configuration files for your app from the rest of the system as well. And so that's what this policy is doing, for example, on vCenter is let's completely harden the environment. So it goes above and beyond the typical things customers do, which is, the NSA STIGs, or they do the CIS recommendations, or other hardening documents. Well, this is sort of an instant hardening and helps you meet, even in VMware's own hardening guideline. I think it's VSH03 requirement basically says, you really should provide Windows system protection where your vCenter server is running. They don't really give you much advice other than to say, well, you should really protect this because this is a critical box and a critical aggregation point in your environment. So, and then to do what you were just talking about separation of management LAN, these are all good practices. Oftentimes customers don't necessarily always implement that.
Ain't that the truth?
Here's an additional level of controls right in the policy that you can configure, and then just through these lists in about 15 minutes you say, okay, what is the allowed IP address range for my vCenter to talk to the ESXi boxes that it's supposed to, or ESX boxes that it's supposed to control? Where do I want to allow clients to come in from? I absolutely want to specify where is my vCenter database, right? Because I have my vCenter application environment running Tomcat and Jetty, but it's talking to a back-end SQL database somewhere. You want that to be a very isolated connection. So you don't want your vCenter somehow going to talk to a different SQL Server database. And oh, by the way, you want to apply these protection policies on that SQL Server system itself. There's no, in most environments, you're going to have your production database systems aren't running any vCenter software themselves. They just happen to be the main control repository of all the information. So you still want to put the standard, for example, Windows protection policy on your SQL Server database. Protect it, and then you can configure the network rules there to say, okay, this database is only supposed to be talking to this particular vCenter platform, or multiple ones if it's set up in more of a high availability environment. So with very simple configuration of your network rules, and again, very simple. I mean, you can do this in 15 minutes if you know your information about what the separation of LANs are, where do I want to talk to my active domain controller, my time source, my SMTP machines for sending alerts to. So from the host itself, you're able to precisely lock down the networking, so you're not going to have your machines talking to China, because you're going to configure what is the scope of this vCenter system. And of course, with vCenter, there's a multiple ancillary utilities. So I have my update manager. It's probably off on a different machine. I have my ESXi dump collector on another machine. You want all of these to be running this policy, and each of those is configured so, the networking is only talking to this box and doing this. And so once you set it up, essentially this operates, and now you've got a hardened environment. It's also providing this tamper protection. Nothing's going to go change those vCenter, not only the binaries, the Tomcat and the Jetty, but all of those config files about Tomcat, comp files and and thinks about how the whole environment is running. It's also locking down where all your logs are. So it prevents log tampering, where only the vCenter software is able to write to its logs. No other process is going to go in there and alter the logs. Again, you need to have this assurance, this integrity of your system, such that when I'm looking at logs elsewhere in the network, how can I be sure that the source of that log is coming from a protected, secured system? Same way with the SSL keys. Very critical that you protect your SSL information on your vCenter servers so that somebody isn't going on able to copy off those keys and then setting up their own man-in-the-middle kind of environment. So it's using the CSP product as a way to really harden, again, not an individual box, but your whole ecosystem, because I could do a good job of protecting the front-end Tomcat part, but if I'm not protecting the database from some attack into the SQL, again, just running a Windows box, then there's multiple points of vulnerability. You want to deploy this across your infrastructure. That's why it's called critical system protection. This is designed to go on those critical assets in your enterprise. And certainly your domain controllers, all of those things are important. Your DMZ, customer-facing systems, your databases, and clearly, the central point of where if I own your vCenter box, I can then own essentially the thousands of VMs underneath of it. I can do copies, I can change the configurations, I can adjust the security settings.
Well, it's even more than that. I mean, you have to, not only do you have to target vCenter, you have to target vCloud or the OpenStack components sitting on top of vCenter. I mean, vSphere.
Absolutely.
You have to target all the other management tools that are out there, like the ones from Embotix, the ones from even Microsoft, the ones from Citrix, the ones from, you name any performance management company, they have one. We need to also harden the high trust environment if we're using that. If I'm talking about a security appliance, I may want to do it for that as well. I'm not sure how that would play in, but it's a possibility. But I actually am thinking one way it can be used that would gain customers visibility in security control when they don't already have it today. For example, if I deploy CSP underneath my cloud environment at the vSphere, vCenter levels, vCloud levels, I, as the tenant, can't see that normally. I have no control over it. All I can say is what's going on, and they may tell me, they may not. But as the tenant, I can get CSP and put it into all of my VMs, my virtual machines, and control my own policy for my own virtual machines.
Absolutely. Yep. Absolutely.
In my own management constructs, whatever they may be, I may have a log server out there. I may have a performance management tool, an APM tool that I control. So as the tenant, something like CSP may be able to give me the visibility I'm lacking with current cloud providers.
Certainly one of the biggest things CSP is giving all of the customers is this huge increase in visibility, what's going on in these systems, situational awareness, where am I exposed in my organization, and again, you particularly the things that are going to be exposed to the internet, and your DMZ, your critical, anything that, for example, let's say like the PCI regulations, any of your critical...
Well, let's think about it as a tenant of the cloud. I mean, as a tenant of the cloud, anything that's in the cloud could be considered critical, because I don't have today no cloud provider that I know of, well, maybe one cloud provider that I know of, will give me the visibility deep into their environment to say, yes, you passed the PCI audit, and the scope of that audit included where my machines are. But if I use something like CSP as a tenant, I may not need that visibility. What do you guys? What does everybody else think of that? Mike? Mike Foley?
Yeah, I'm thinking through this.
Eben, well, if you're not ready, Eben, you ready to say something on that subject?
I agree that if you can run that locally inside the VMs, then that would give you that visibility that you want. That's great.
But will it give me enough protection? Michael, Michael Berman, would that give me enough protection going forward?
Well, it depends on who's defining enough, right?
Yeah, and these are compensating controls.
One person at a time. Michael first.
Okay, so, what I like about this product, and I don't want to call out warts on any other product from the same vendor, but we all know that traditional antivirus has probably reached its limits. And this is clearly a technology that takes us to that next level because it's not depending on signatures at all. It's depending on behaviors, known good access profiles, and the ability to spot when an object or a user is doing something that is not within that normal framework. So this is critical to the issues of endpoint security. I don't believe that even if we had perfect endpoint security, we then don't need perfect endpoint security does not make network security obsolete. Right?
I would agree with you there.
So,
I'm plugging out the tenant. Yeah. I can't see underneath me into the hypervisor. I can't see into any other constructs I may have. All I can see is my little piece of the network and my VMs.
Well, what I also like about this is there's certain cloud models where you can't, take a solution like, speaking of one I know very well, a network-based data plane, hypervisor-based solution. You're not going to get that into Amazon anytime soon. A lot of other cloud providers aren't going to let you as a customer deploy something like, like a Catbird or a Reflex, or potentially even a vShield app.
Mm-hmm.
So this is an important alternative for, customers, for consumers, to be able to have better control of what's going on in the cloud. Now, that doesn't mean they should stop worrying about what's happening in the cloud provider layers. But,
they still need better visibility into what the infrastructure is that all this stuff's running on.
Yeah.
Okay, so this can't substitute for the visibility into the infrastructure.
Yeah, I wouldn't classify any product that's running within my VM as, well, it's okay for me to put sensitive data out in the cloud and I don't have to worry, because at the end of the day I'm responsible for the audit. And if I don't know or even control the whole infrastructure underneath, how can I be sure?
Okay. Eben, you were saying something?
Well, I was just saying this is a compensating control in many cases where you may not be able to control it, but you would at least be able to detect it and possibly take a compensating action.
Okay. I do have one more bit. My worry is with any product such as this, and I'm not trying to isolate this particular product because up until prior to this call I really hadn't looked at it very deeply. Anything that has an agent in it means that agent's running at the same level as the malware that could get on that product and could defeat it. That's kind of why I like the way VMware is doing things from an agentless standpoint.
So you think CSP should be at a much lower level?
Oh yeah.
Well, but it is, once it's installed, it's running in the kernel of the VM.
Well, it's basically running as a rootkit. I mean, come on, let's be real about it. You just shim the whole operating system by trapping sys commands, and that's easy. And every rootkit does that as well. So who's to say a rootkit wouldn't get below you?
Right.
Well, once this is in, you'd have to figure out how to get. And he brought this up in the context of Stuxnet or Aduku or whatever. Is that if CSP is installed first, you've made that attacker's job a lot harder.
Absolutely.
And then the one piece that I didn't hear, and maybe it's there and I just didn't hear it, is there a trusted execution component to CSP?
Well, in terms of the tying into sort of the platform modules underneath, those kinds of things?
TPM, TXP, yeah.
Exactly.
I mean, at this point, it's basically working across all of these environments. There's nothing special that ties it into trusted hardware boot up and those kinds of things, because this gets deployed in many environments that don't have that class capability yet. Not to say in the future it can't be extended to sort of work in conjunction with that, so you get this trusted boot up, and then, again, you're kind of relying on CSP to provide that protection. And coming back to the point that was just made about if it's a dirty box already, and now you put CSP on, it's a very valid issue that, okay, if something is already on that box at the kernel level, then you're right, CSP is not going to then prevent that malware necessarily from running, although generally what we do see is that when CSP is put on a dirty box, you'll start seeing some of the malware behavior starting to expose itself as well. So you might say, something's going on there. Clearly,
because the malware doesn't know to spoof CSP.
That's right.
Yeah.
And so generally, obviously, we would say start with a good known gold image, then you apply CSP, and then this is what's giving you that sort of integrity and absolutely preventing these new exploits from getting into the system, burrowing into the rootkits and those kinds of things.
Okay. So we're at the end of our hour. Any last thoughts? We'll start with Alan.
Just that, again, the product's been around for quite a while, and then certainly what's new here with virtualization is simply just more policy content capability out of the box to make this easy for customers to deploy.
Ethan?
I like it. I'd like to see it in action.
Okay. Michael?
I think it's certainly a superior approach to a lot of typical endpoint anti-malware solutions. I love the fact that the people who came into this initial development were coming out of the B2 or B3 trusted system development space. That's certainly the right lineage for this kind of tool.
Hey, Mike?
It's yet another tool in the security guys tool belt. Like I would say about any particular tool, there is no one be-all, end-all. Because the attack vectors are changing daily, hourly. You've got to use whatever tool is available and a combination of tools. And it coming from that lineage, I particularly like that.
So do I. It's kind of like whitelisting on steroids.
Yeah.
It's the way I'm thinking about it, and I think that's actually a very valid approach to it. I would like to see it at the VM container layer as well. I think that would be extremely cool, because there's only one problem that worries everybody, and there's absolutely no protections from it today, and that is escaping the VM.
Oh, I wouldn't go that far, Ed. I mean, I'm not here to present VMware's case, but VMware's done a good job on the VM.
I mean, every hypervisor does an extremely good job on it.
Yeah, and they're the right people to worry about it and try to repair it. And that could be a high level relationship between this unit of Symantec and VMware, is to look at what sort of cross licensing they could do. I mean, what I would prefer is not to see VMware reinvent the wheel in this area.
I would absolutely agree there. I mean, I know VMware, Microsoft, Zen, the Citrix folks, the Zen folks, the Red Hat and KVM folks have done a lot of work to prevent escape the VMs, and they're continuing to do it, but eventually it'll happen. We all know it. And right now there's no way to prevent it. There's no preventative. There's no anything I can use, and I would love to see something to help prevent it.
You're depending on the current design.
Excuse me?
You're depending on the current design to hope that it's not going to happen.
Correct.
Right.
And I would rather depend on something I can monitor.
Yeah, and based on a fairly lengthy track record, a company like VMware probably won't license that type of a technology. They would probably create APIs that a third party could then code to. That's just been, the experience of almost anyone dealing with VMware.
And I will say, in the case where you can use this tool on the Cons OS, right, and you are monitoring VMX files or other files in Cons OS, and this is where perhaps having modified which files could be monitored, and that was interesting when you brought that up earlier. Is that right now VMware exposes very few files, but a customer could go into that XML and expose more files. Might be interesting, really, to see what would be your recommendation for that particular configuration, because obviously the more you monitor, the better, right? And what I was getting at is that if you're monitoring the right files on the Cons OS or elsewhere, where is that VM escape going to? That VM escape is going to another VM, or it's going into the hypervisor. And if it's going into the hypervisor, it may eventually touch one of these files that's being monitored, and that could be interesting.
Okay.
That's right. I would really like to see etc password, etc group, and a few more really critical files to be added to that list by VMware. And one final comment, I absolutely agree with the speaker who was saying, look, this CSP is, again, just one technology capability. You have to have the layers of defense. You still need your network perimeter activity. You would still want to combine this with even things like AV if you want to do the packet inspection, for example, coming in over the network. AV has very nice remediation capabilities of quarantining and cleaning up things. And of course you want DLP, use encryption where appropriate. So for endpoint protection, again, it's not CSP is the end-all be-all story. It's all done in combination, all the defense in depth everybody knows about.
Okay. Well, thank you everybody for joining us, and I hope everybody enjoyed the podcast. Thank you very much. Alan, have a great day.
Thank you very much.